Morning to you all. Yesterday we have seen how to obtain state space model of mechanical system and the electrical system. Today we are going to see obtain the controllable canonical form for the given transfer function. Obtain the controllable canonical form for the given transfer function. Obtain controllable canonical form of realization means finding physical system. So the first step is h of s can be written as y of s upon x of s equal to y of s upon x1 of s multiplied by x1 of s upon x of s. That is equal to s square plus 2s plus 3 multiplied by 1 upon s power 4 plus 3s cube plus 12s square plus 9s plus 8. This is equal to this is equal to this. This is equal to this. Now we have to take the second one. If you cross multiply, what you will get? S power 4 plus 3s cube plus 12s square plus 9s plus 8 multiplied by x1 of s equal to x of s. Or you can say that x1 of s power 4 means fourth derivative plus 3 times x1 third derivative plus 12 times second derivative plus 9 times first derivative plus 8 x1 equal to x of t. x1 fourth derivative of x1 of t, third derivative of x1 of t, second derivative, first derivative without any derivative. Let us assume that x1 fourth derivative of x1 of t equal to x of t minus 3 third derivative minus 12 times second derivative minus 9 times first derivative minus 8 times x1. This is how it can be simulated. Let us assume that x1 is available. Let us assume that x1 of t is available. x1 of t is available. If we assume x1 of t is available, we are going to give x of t as input because it is plus sign. And this is, let us assume that we are assuming that x1 fourth derivative is available. x1 fourth derivative is available. If you integrate once, what you will get? If you integrate once, you will get here what you are getting is x1 3 dot. x1 fourth dot is integrated means x1 3 dot you will get. Once again, if you integrate, what you will get? x1 double dot you will get. Once again, if you integrate, you will get here x1 dot you will get. If you integrate one more times, you will get x1 of t. We are assuming that x1 of t is available. If you integrate x1 to the fourth derivative is integrated, you will get the third derivative. Once again integrated, you will get the second derivative. If you integrate first derivative, you will get x. So 4 integrators are in cascaded form. 4 integrators are in cascaded form. Now, x1 to the power 4, fourth derivative is available. We are thinking, assuming that this is available. But this is equal to what? X of t. That is given here. What are the remaining things we have to give? These are the 4 elements that we have to give. Third derivative is available here. Third derivative is available here. How many times we have to multiply? 3 times we have to multiply. And we have to subtract from this. So we got this and this we got now. This and this we got subtracted. Now 12 times second derivative we have to subtract. 12 times second derivative. So 12. That is also subtracted from the summing block. 9. This is also over. Now 9 times first derivative. Take this, multiply by 9 and subtract. Then take 8 times of x1. That is also has to be subtracted. So all are subtracted from the summing junction. You got x1 of t. Now x1 of t is available. Now take the first equation. What is that? Y of s upon x1 of s is the first equation. That is equal to s square plus 2s plus 3. Cross multiply. Y of s equal to what? Y of s equal to s square x1 of s plus 2s x1 of s plus 3 x1 of s. S square means second derivative, x1 double dot plus 2 times s means first derivative, x1 of t plus 3 times x1. So take double derivative. Double derivative is available here. Add together to get y of s. Double derivative. 2 times single derivative. Sorry, this is third derivative. Double derivative is taken here. Single derivative. How many times we have to multiply? Single derivative 2 times. Multiply by 2, add with this. Add here. 3 times x1. 3 times x1. 2 times x1 dot, 1 time x double dot and x1. If you add all together, you will get y of t. This is output. This is input. So what is required to design this system? 4 integrators. That's all. If you have 4 integrators and 2 summing blocks, if you have, you can design this transfer function. 4th order system you can design. This is in controllable canonical form. Controllable canonical form. We have seen how to obtain controllable canonical form of realization. After realization, we can obtain controllable canonical form of state model also we can get from this realization. That we will see now. From this we can get controllable state model. Now from this we can get controllable state model. So first we got from transfer function, we got controllable canonical realization. That is physical model. From that physical model, we can get a state model which is controllable. Controllable state model. To obtain that, this is x1. Therefore, here it is x1 dot. This is x1 means this is x1 dot. Therefore, x1 dot equal to what? x2. This is x2. Therefore, before integration, it is x2 dot. This is x2 dot means what? This is x3. x3 means before that it must be x3 dot. x3 dot equal to what? x3 dot equal to x4. Before x4, what will be there? x4 dot will be there. That's all. Now we can write the
the equation. Here we can put equal to x1 dot equal to x2, x2 dot equal to x3, x3 dot equal to x4, x4 dot equal to sum of all these things. So we can write the equation x1 dot equal to x2, x2 dot equal to x3, x3 dot equal to x4, and x4 dot equal to what? Sum of all these things, that is x of t minus 3 times here you notice that 3 times minus 3 times x4 minus 3 times x4 minus 12 times x3 minus 12 times x3 minus 9 times x2 minus 8 times x1 that is x4 dot. So we can put this in matrix form as x1 dot, x2 dot, x3 dot, and x4 dot equal to, this is a state matrix, A matrix. Here you will have x1, x2, x3, x4 plus this is B matrix multiplied by x of t is the input. Now what is the x1 dot equal to x2? Therefore we can write 0, 1, 0, 0. x2 dot equal to x3, therefore 0, 0, 1, 0. x3 dot equal to x4, 0, 0, 0, 1. And x4 dot equal to minus 8 times x1 minus 9 times x2 minus 12 times x3 minus 3 times x4. And this has x of t, that's say 1. All other no x of t, therefore 0. That's all. This is A matrix, and this is A matrix. This is A matrix, and this is B matrix. That's all. This is controllable state model. That's all. Sometimes and the examiner may ask you to find the controllable state model instead of realization. In that, you have to physically realize first, then you have to name like this. How to name that? The final output is x1. So before the integration, it must be x1 dot. This is x1 dot means it is equal to x2. Before x2, it must be x2 dot. This x2 dot must be equal to x3. Before integration, x3 must be x3 dot. That is equal to x4. Before x4, it must be x4 dot. That's all. But x4 dot is sum of all these things. That's why we got this equation. Notice that in controllable canonical form, the last row, A matrix has last row all elements, and all other rows it has off diagonal elements. These are all called off diagonal elements. So if this is in this pattern, then it is in controllable canonical form. A matrix is in this pattern, it is controllable canonical form.